All right, let's get into it. We all kind of take that little blue dot on our maps for granted, right? But have you ever really stopped to think about the incredible web of satellites that makes it all work? Well, today we're going on a trip way beyond the GPS we all know, to meet the entire global team of navigators that are mapping our world from high up in space. So, here's a question for you. When your phone magically finds your location in like 2 seconds, who's it actually talking to up there? Which satellite is answering the call? If your first thought was GPS, well, you're not wrong, but you're only seeing a tiny piece of the puzzle. The truth is, your phone is probably chatting with a whole fleet of systems from all over the world. It's a busy place up there, and honestly, that's a really good thing for all of us. So, first up, let's talk about a system with a pretty dramatic history. We're kicking things off with Russia's GLONASS. And this isn't just some tech spec story, no. This is a story about a system that was built, nearly died, and then was brought back from the absolute brink. So get this. GLONASS launched its first bird back in '82 and was fully up and running by '95. But then, the funding just dried up. The system basically fell apart. By 2002, there were only 7 satellites left working. It took a massive, dedicated government push to resurrect the whole constellation by 2011, and now they're constantly upgrading it. It's a wild story of near-total failure and an incredible recovery. So let's look at how it's built, because it's a little different. GLONASS uses 24 satellites, but it packs them into just 3 orbital planes, while GPS uses 6. They also fly a little lower and at a much steeper angle. This whole setup makes the system incredibly resilient. It was designed so it could keep working even if a few satellites went down, a lesson they clearly learned the hard way. And here is the biggest technical twist. Most other systems have their satellites share frequencies. GLONASS doesn't. It uses something called FDMA. The easiest way to think about it is that every single satellite gets its own private radio station. It's a totally unique approach, and it's a world away from what Europe decided to do. Okay, now let's talk about Europe's Galileo system. And the most important thing to know about Galileo isn't just the tech, it's the entire philosophy behind it. It was designed from day one with civilian control as the #1 priority. And that idea of civilian control is absolutely fundamental. See, the worry was that systems with military roots, like GPS, could, have their civilian signals weakened or even shut off during a major conflict. Europe wanted a system they could count on no matter what, one that was run by civilians for civilians. And that's a huge deal for things like air traffic control, where you just can't have any uncertainty. This focus lets Galileo offer some really unique services. Of course, there's the free open service that everyone can use, but there's also a super accurate encrypted service that gets you down to centimeter-level precision. It's got a safety of life service that sends out warnings if a signal is wonky, and this is my favorite part. Its search and rescue function can actually send a signal back to a distress beacon, letting the person know that help is on the way. How incredible is that? Now, check out this number. 23,222 kilometers. That's how high Galileo's satellites are flying. That's way higher than GPS or GLONASS. And it's not just for fun. Flying higher means each satellite sees a bigger slice of the Earth, which gives us better, stronger coverage, especially way up north or down south, where other systems can sometimes struggle. All right, let's turn our attention to the newest global player on the block, China's Beidou system. The story here is all about speed and a design that is completely different from everyone else's. Seriously, it's hard to overstate how fast this happened. In just 13 years, Beidou went from being just a regional service to a full-blown global powerhouse. It's named after the Big Dipper, and its rollout was one of the quickest and most ambitious infrastructure projects you'll ever see. Okay, Beidou's secret weapon is its really clever mixed orbit design. It uses 3 different kinds of satellites. Think of the high-altitude GEO and IGSO satellites as these powerful spotlights that just hover over the Asia-Pacific region, giving it extra strong service. Then, you've got this big fleet of MEO satellites that are constantly circling the globe to provide worldwide coverage. It's this genius hybrid approach that gives it both super strong regional power and global reach. And right from the start, Beidou was built to do more than just find your location. It actually has a 2-way short messaging service built in, so you could literally send a text from the middle of nowhere with no cell service. And just like Galileo, it's also part of the International Search and Rescue Network. It's a real multi-tool. But here's the thing. Not everyone is trying to cover the entire planet. Some countries are playing a different game entirely.
They're focusing on becoming the absolute masters of their own backyards. Let's look at the regional specialists, Japan and India. For these two, the strategy is totally different. They're not trying to replace GPS or Galileo. The goal is to make those global systems even better in their home countries. They're trying to achieve navigational perfection, especially in really tough spots, like cities packed with skyscrapers or deep mountain valleys.
Japan's solution to this is it's brilliant. Their system, which they call Michibiki, uses this very special kind of orbit, a quasi-zenith orbit. It's not a circle. It's this long, stretched-out ellipse that makes the satellite trace a figure-8 pattern in the sky over their part of the world. And the genius of this weird orbit is that it makes the satellites kinda hang out high in the sky over Japan for more than 12 hours a day. So if you're on the ground, it means there's almost always a satellite nearly straight up, and that is the absolute perfect angle to get a signal, even when you're standing between two giant buildings.
Over in India, they've built their own system, called Navic, to do basically the same thing. It uses its own set of satellites to blanket the Indian subcontinent and the areas around it with super reliable positioning, giving them navigational independence and just plain better service.
So what do we have? We've got global systems and we've got regional specialists, all orbiting Earth at the same time. It's just an amazing display of engineering, cooperation, and, yeah, a little bit of competition.
But let's bring it all back down to Earth. What does this crowded sky, this big global space race, what does it actually mean for the phone in your pocket or the navigation system in your car?
Well, the answer is a massive upgrade for every single one of us. See, modern phones aren't just listening for GPS anymore. They're listening for GLONASS, Galileo, and Beidou all at once. That means you get a lock on your position way faster. It means you get much better accuracy because your phone is using more signals to pinpoint you. And it means incredible reliability. If a building is blocking a few GPS satellites, who cares? Your phone just tunes into the Galileo or Beidou ones instead. It's the power of having choices. So the next time you see that little blue dot, just take a second to remember the whole international fleet of satellites making it happen. And it leaves us with one final big question. As this technology becomes more and more vital to everything we do, who is actually drawing the map of our connected future?